So our next lesson on quadratics, we're going to look at graphs of quadratic functions, certain features of those graphs, and then also the different forms of quadratics and how we can transfer from one form to another, what those forms are good for, how do we use a calculator if we need to. All right, so there's three forms of quadratics that we're going to talk about, and the first one is sometimes referred to as polynomial form. Other times books refer to this as standard form. And standard form is probably not the greatest form for us to be working in. It does tell us some things though. So let's talk about how we can find x-intercepts. There's a few different ways. X-intercepts are where your function equals 0. So if you were to take your function and set it equal to 0, and then you would try to solve it. So for finding x-intercepts by hand, and you want to solve a quadratic function, you have a bunch of different methods. One thing I noticed is all these coefficients are divisible by 2. So I'm going to go ahead and do that. And then I have a simpler quadratic to solve. And then believe it or not, your favorite method for solving quadratics is probably to see if it factors. And if I do a little bit of mental math here, I see that this one does factor. This one factors into x minus 3 times x plus 1 for my factors. So when I set each of these factors equal to 0, I get solutions of x equals 3 and x equals negative 1. Well, those solutions happen to be my x-intercepts. So we're going to have one at x equals 3 and x equals negative 1. So you know how my graphs go, so let's see how this works. It's going to cross the x-axis at negative 1 and also at 3. The next component is the y-intercept. So the y-intercept is what happens when you take your function and you substitute in 0 for the x value. So you can go back to the original function. 2 times 0 squared minus 4 times 0 and then minus 6. Well, this is kind of neat because anything with an x term is going to essentially cancel out because of the 0, which just leaves you with this last part of standard form, which is the c value. So y equals negative 6 is going to be your y-intercept. And let's see, 1, 2, 3, 4, 5, 6. Ooh, fell off the axis. Okay. Yeah. Now notice we didn't find the vertex yet. The vertex is something that in standard form it's easily found using a formula, but we don't have it quite yet. So the vertex is the center point of the parabola, and it's going to be an ordered pair. And the way we calculate the x value of the center point of the parabola, a couple different ways. You could use the axis of symmetry formula, negative b over 2a. Or if you already have the x-intercept, it has to be smack dab in the middle of them. So if you think about what is in the middle of 3 and negative 1, that would be the same thing as averaging 3 plus negative 1 divided by 2. So 2 divided by 2 is going to be a 1. It would have given you x equals 1 regardless of which formula you used, but I was kind of working with what I had. And then to find the corresponding y value for the vertex, you would have to substitute in the 1 into the function. So 2 times 1 squared minus 4 times 1 minus 6. That would be a 2 minus 4 minus 6, negative 8. So our vertex is down here at 1, negative 8, somewhere here. And then I know I should be able to graph and make it like a beautiful oh, see? Oh, okay. Again, I'm on oh boy. Okay, even for me, this is like exceptionally bad. So you're on a paper and pencil. I'm on a tablet. Give me a little grace here. The point is, I could have found all the things algebraically. I also, because of, being the year 2017 now, I have a graphing calculator, that could find a lot of these things for me. So it's nice to be flexible. And if you can use no calculator, awesome, because there might be a moment in your life where you can't use a calculator. The SAT, remember, a big chunk of the test is no calculator. But if it's on an assessment and you're trying to just kind of save your energy and you have a calculator available to you, all these things could be found through the calculator. Oh, one thing before I move on. In that form, pretty much everything took a whole lot of work. I mean, comparatively speaking to most of the things we do in PreCalc, not that much work, but I would say the one thing that was super easy to find in standard form was the y-intercept. That was just an identification of the c value in your formula. Everything else took a little bit of effort. So if you want to know what polynomial or standard form is good for in a quadratic, it's really good for finding y-intercept. So let's talk about vertex, or sometimes referred to as transformational form. Vertex form because you can easily identify the vertex. The vertex, remember, is at the point hk. So the general expression for vertex form is a times x minus h squared plus k. And the reason, again, it's called vertex form is because it's at the location h comma k. So if you could figure out who H and K are, you know where the vertex is. The reason this is also called transformational form is because it identifies the vertical and horizontal transformations pretty easily. Also, you can easily identify any sort of vertical stretches or compression and reflections. So, it's a good form. It's my favorite form. And the first thing that I usually pick out when I figure out where the when I'm trying to fill this out is if it's vertex form, I know what the vertex is. The vertex is at HK, right? So I lost my formula. So if I go back up to my formula, the one thing we have to remember about vertex form, this is x minus h. So it's really x minus a -5. That's why it translated over to an x plus 5. So the vertex is actually at -5, -4. A lot of kids in Algebra 2, when they're first learning this, or even Algebra 1, they start thinking like, oh, I'm supposed to take the opposite of that h value. It's not really what you're doing. Jeez, I have like a goldfish memory today. What was it, K? -4. Um, so it's not that you're just taking the opposite. Not quite that simple, but if that helps you trigger your memory that something weird happens because of the built-in negative, that's fine. Now the x-intercepts, I could find algebraically. Remember, x-intercepts are what happens when your when your function is set equal to 0, and then you try to solve it, right? So a little bit of bad news here. Got a little bit of work to do. So I would personally, I would start by adding the 4 over. 4, hello. And then I would divide both sides by -3. Oh, you know what? This isn't actually going to have as much work as I thought. We're actually going to stop like right after this step. -4/3 equals something squared. So my next step algebraically, I mean, I could like FOIL x plus 5 times x plus 5 out, but I would try to square root both sides of this equation. That's the most effective way. But think about what happens when you square root something that's negative like this. You're going to end up with answers that are i's. I's indicate that they're imaginary solutions, which are not real solutions. So this parabola, wherever he's located, which I'm going to find out in a minute, doesn't even cross the x-axis at all. So there are no x-intercepts, so we'll say none, because they're the solutions are imaginary. We could have figured that out if I found my discriminant. Would have saved me a little time. Oh well. And then the y-intercept remembers what happens when you take your function and you were to substitute in x equals 0. So y equals -3, we're plugging in a 0, so 0 plus 5 squared minus 4. Let's see, that's 25. So -3 times 25 is -75, and then minus 4, -79. Oh, yes, of course. So the y-intercept is way down at -79. The vertex, I could have kind of plotted that, I suppose, is -5, -4, like somewhere like right here, and then like way down here across. Oh, it's not even. So we have like a really thin down opening quadratic. I'm just gonna really fudge it in and just draw something like awful. The point there is in vertex form, the easiest thing to find for us, the thing that requires the least amount of work, is the vertex. But I could find the other components if I needed to. And then our last form is x-intercept formed. I'm sure you won't be shocked to hear that the easiest thing to find here are the x-intercepts. This is also known as factored form. So they've done the algebra, they've set it up as a product of two factors. And remember, x-intercepts are what happens when you solve the quadratic by setting it equal to 0. Well, since it's already factored, 1/2 doesn't have a variable, so that will never equal 0. I'm not going to worry about that. But if I solve each of these factors, I get an x-intercept at 5 and at -3. So like, you know, kind of fudge this in. Since my graph's going to look so awesome, right? Next thing I have to find is the y-intercept, which I can't easily identify. I have to do a little bit of work. Y-intercepts are when your x is substituted in as a 0. So 1/2, 0 minus 5 times 0 plus 3. So let's see, that's 1/2 times -15. So it'd be like -7.5. So like down here. But remember, that is not the vertex. We have not found the vertex yet. So it's not in standard form. I would not suggest finding the -b over 2a to find the axis of symmetry. That's not a smart move right now. I would use that midpoint formula where I know my vertex, the axis of symmetry, the x value of the vertex has to be smack dab in the middle of it, which I know a lot of kids are like trying to visualize it. I graph really terribly, so I wouldn't suggest that. But I do know that instead of using negative b over 2a, forget that, I can just take my two solutions, my two x-intercepts, and find the middle. 2 over 2 is 1. So for my vertex, I know the x value is a 1, so it's the axis of symmetry is somewhere there. And if I were to plug in x equals 1 to my formula, I get 1/2, 1 minus 5 times 1 plus 3. So let's see, that's negative 4 times 4, it's negative 16. 1/2 of negative 16 would be negative 8 is the y value. Again, a lot of these things could have been found. Hey, look at that. Let's see if I really, oh man, I should like buy a lottery ticket. That was awesome. So if got so excited for my graph. Vertex form, vertex was easily found. X-intercept form, the x-intercepts were easily found. Standard form, the y-intercept, I guess, was interesting. That's about it. But all of those things could have been confirmed or found in the first place on a graphing calculator if that's where you wanted to start. Now, what if you weren't allowed to have a graphing calculator? What if you had to do some algebraic work and you were asked to change from one form to another? So there's a couple of different algebraic ways we can do this. And I'm always for using your resources. So we will also talk about follow-up options if we're ever in a situation where I am given a graphing calculator. And let's say it's not something where my teacher said, you must show work, you must show this method. If they just said, find it. For me, that means game on. Like I can do whatever method I want. So let's talk about some options. I don't know what's going to be on your SAT test, guys. So we got to be careful. I'm out. Logan, can you turn that down, please? Yes, please turn it down. You can hear leapfrog in the back. I'm really sorry. All right, so change the x-intercept form. Fancy talk for change it to factored form. I know how to factor. That's really not that hard to do. Now, if I already knew what the x-intercepts were, that's cool, but it's just as easy for me to go ahead and factor this. This is going to factor into x minus 5 times x minus 1. Voila, done. All right, the next problem, another standard form parabola, but this time they want me to change it to vertex form. So you have two methods. You can either find the vertex somehow, or you can complete the square to write it in vertex form. I will show you both because I kind of like them both. Finding the x value of your vertex, remember, is negative b over 2a. So for us, negative b would be positive 4 over 2 times a. 2 times 1 is 2. So my x value of my vertex is at 2. I would have to go substitute that back into the formula to find the y value. So let's see, 2 squared is 4, minus 4 times 2 is 8, plus 1 is negative 3. So if I can now take that vertex and slide it into vertex form, I'm good to go. Notice that there's a 1 in front, so you don't have to worry about any sort of vertical stretch. So the x minus 2 squared, just remember opposite signs, and then the k is negative 3. Now the other method is to kind of use a modified version of completing the square. This is my favorite version. I just really like completing the square. I don't know why. So keep everything on one side of the equation sign. You're going to use this partial quadratic, and you are going to complete his square. But that weird plus 1 that was already on the c value, he's kind of off to the side. But remember, we got to keep things balanced. I can't just like add a random number into an equation and then say, yeah, good. Normally, in completing the square to solve, we would add the blank to both sides of the equation. Since we're all on the one side of the equation, instead of adding it twice, we're going to add it once and then subtract it once on the same side. So let's figure out what goes in the blank. Half of negative 4 squared is 2, squared is 4. We're adding 4 and then we're subtracting 4. And I know at first kids learn this and they're like, why'd you do that? Stupid. No, it's not, because look, this is now x minus 2 squared. And then if I collect these, it's a negative 3. So look, both methods gave you the same vertex form. It is totally up to you. I have a strong passion for completing the square, so I really enjoy it. There's a bit of a drawback though, trying to use the completing the square formula, and it happens right here. So we'll talk about that in a second. Let's do the other form first, the vertex form. So finding the x value, negative b, so 12 over 2 times a, 2 times 2 is 4. So 12 over 4 is 3. So the vertex is at 3 comma something. So we got to plug in that 3, right? 3 squared is 9. 2 times 9 is 18. Minus 36 plus 7 plus negative 18 plus 7, so negative 11. So now I have to go back and put it into vertex form. But remember how the a value originally was a 2? That means that your a value in vertex form is also going to be a 2. And then x minus 3 squared minus 11. Let's look at vertex, completing the square to get vertex form. Same problem though, so we're going to get the same solution. Here's the idea. Still going to kind of group those first two parts of the original quadratic together, except you're going to notice that that first value is not, oops, subtract. You. Like I was saying, the first coefficient is not a 1. So remember, you can't actually complete the square unless this first coefficient is a 1. So when we were solving, it was easy. We just divided everything by 2. Well, you can't divide in a function equation because it has to stay equivalent. So what we're going to do is we're going to factor out the 2. Okay. So this becomes now x squared minus 6x plus something plus 7 minus something. All right, so let's figure out what goes in that blank. Half of negative 6 squared would be a 9. But you're not going to subtract 9 over there. This is really an 18. We're subtracting an 18 right there. So let's see what we end up with. 2, and then this is now x minus 3 squared. Oh, what do you know? Minus 11. So we end up with the same exact equation or function. It doesn't matter. That was my 4-year-old. Moving on. All right. So quadratics can be written in standard form as long as we need to be able to identify. Hi. Hi. Well, they can't see you when you're over there. Say hi. That's hi. Okay. All right, go back and watch. You gotta make it quieter now. We should be able to identify the vertex, the line of symmetry, and then whether it's opening up or down. And a few different methods. Sketch. Use the negative b over 2a formula, complete the square. So that's quiet enough. Thank you. So what they want us to do is to answer all those questions. The first problem I'm looking at is in vertex form. So I can just go ahead and tell you what the vertex is. It's at 5, 6. And then the next question is the line of symmetry. Well, the line of symmetry is sometimes called the axis of symmetry. Remember, it's the vertical line that goes through the vertex. So it's whatever this x value of the vertex is, that is the axis of symmetry. So for us, it's x equals 5. And then whether it's opening up or down is dependent on the a value. This is a positive a value, so it's going to open up. So I already knew all of those things without doing anything on the graphing calculator. This next problem is also in vertex form. I should be able to find the vertex pretty quickly. Negative 3, 7. The axis of symmetry or the line of symmetry is going to go through the x value of the vertex, x equals negative 3. And then because the a value, is negative, it's going to open down. And then, not in vertex form. So you choose your favorite method here about, we got to find the vertex. So, my favorite method is completing the square. This is going to be one of those trickier ones where you have to factor out the 2 before you can complete the square and then kind of identify that you've multiplied that whole factor by a 2. If you would prefer to use the negative b over 2a to find the vertex, that's totally fine. Up to you. I just, me, I love completing the square. So if I go ahead and take a 2 out of these first two parts, that leaves me with x squared minus 3x plus something. And then, was that a plus 13? And then we're going to have to subtract something. So half of negative 3 is negative 3 halves, and then squaring that is 9 halves. Now I kind of regret my decision because now we fraction. But remember, this is not minus 9 halves over here because it's 2 times 9 halves. So it's actually a minus 9. So that worked out kind of nice. I don't regret my decision. This was beautiful. All right, 2x minus, it'll be 3 halves, remember, as your factor, squared, plus 4. I feel like I messed up somewhere there. I don't know. Not sure if I messed up or not. Either way, the vertex. Well, let's see. No, I feel good about that. My key says something different. If it's wrong, it's wrong. Sorry. You know what, guys? This is 4th of July. The fireworks are about to start. I'm really excited to finish this problem. All right, so according to my work here, the vertex is at 3 halves 4, maybe. On my key, I have 3 halves, comma 17 halves, so I don't know what happened. Its axis of symmetry is x equals 3 halves through the vertex x coordinate, and the a value is a positive 2, so it's going to open up. All right. Oh, bummer. Standard form, standard form. I mixed it up. Okay, let's find the vertex through that axis of symmetry formula. So negative b over 2a, remember, is the formula for the x value. So negative b would be negative 18 over 2 times a. So that would be negative 18 over negative 6. That would be a 3. So my vertex is at 3 comma. Now let's figure out the rest of it. So let's see, negative 3 times 3 squared. So negative 3 times 9 is negative 27. Plus, oh boy, let's see, 3, 50, 56, right? No, gosh, negative, Pete's sake. Why you don't do math at night, guys? You should all do your homework right when you wake up in the morning, right? No, that's a bad idea. 3, 4, 54, negative 54. There we go, minus 1. All right, so when no, something's wrong. Oh my goodness, it's Russo. Not negative, it's positive 3. Positive 54. Okay, 27 minus 1 is 26. Yeah. Okay, so there's our vertex. Oi, oi, oi. The a value is a negative 3, which means this is going to open down. I kind of skipped one. Sorry about that. And the axis of symmetry, or the line of symmetry, is at x equals 3. Whew. I don't know how many more lessons I should record today, guys. All right, now be careful. This one is not quite ordered in standard form. If you want to rearrange the order, that might be smart. You know what? As much as I love completing the square, there's no way I'm going to complete the square on this one because I'd have to factor out a 5, and that's not going to be pretty. We could. I'm not going to. So I'm going to use that formula, x equals negative b over 2a, to find the center of the vertex x value. Line of symmetry. So negative b would be 6. 2 times a, which is 10. And I should reduce that to a 3/5. Now, if you wrote these as decimals, that's probably okay because of, we're graphing. So who's going to graph a point at 3/5 comma anything? But 3/5 is 0.6, by the way. You know what? As great as I am as plugging things in here, let's see. 12 minus 6 times 3/5 plus 5 times, I'm going to go ahead and square 3/5 and call it 9/25, because, yeah. And I think it comes out to 51/5. I'm going to be honest. I think I typed it in my calculator. So as bad as today is going for me, I'm just hoping I did that right. Oh, there's the problem, Bruzo back. There's the vertex, the axis of symmetry, or the line of symmetry is x equals 3/5. And then it has a, where are we at? Positive a value, so it's going to open up. Okay, great. So we're going to find the equation of the parabola, information, start with the vertex, yada yada, so on and so on. All right. So it would be awesome if ordered pairs were like given to me somewhere along the side of the parabola, because it's a little bit open to interpretation as far as like where the ordered pairs are on these graphs. So if this was given to you on a test for me, summative, I would plot like which ordered pairs I want you to use for these formulas, right? So let's look at what we know. So this ordered pair is at 2, 1. I can see that pretty clearly. Another ordered pair that lies along this curve, I think I went with this guy up here, which is the ordered pair 1, 2. So the vertex is where I'm going to start my problem. He is my H and he is my K. And I know from my formula, Vertex Form formula, that I can start putting numbers in places, right? So the other ordered pair is going to come into play because he's some random xy ordered pair. So I'm going to use an x value of 1 when y equals 2, and then I'm going to be able to plug in something for x, y, h, and k, leaving just a as an unknown, and then I can solve for a. That's the whole point. I can tell from the way the graph looks that a looks pretty normal, traditional, if you will. Not real skinny, this graph. I also noticed that it is opening up. The a has to be positive, so keep that in mind as we solve. So using this y as 2 equals, I don't know my a value, and then using this x as 1 minus h, which is 2, it's confusing because they're both 1 and 2, squared, and then plus this k value, 1. I should have color-coded that better, my bad. Next one, I'll totally color-code, okay? So we're going to solve. You don't have to be real, like, doesn't have to look pretty when you're solving this, right? I don't really care if coefficients are in front or not. 1 minus 2 is negative 1. Negative 1 squared is 1. So if I was solving that equation, next step I would subtract the 1 over and get 1 equals a times 1. And then in theory, I would divide by 1 on both sides. It turns out I kind of predicted this a value is 1. So now we're going to go back to the formula. You're going to leave y and x as variables because it's a function, but everything else is going to get a number replaced. So you don't have to write 1 for a, but you can. And then x minus the h, which is 2, squared, plus k, which is 1. There be our formula. All right, this one, I promise the color code, all right? The vertex is at negative 2, 3, it looks like. So there's your h and k. And then an ordered pair that I chose to use is this guy right here, which is negative 1, 0. So going to my formula, my vertex formula, I'm going to plug in something for y, x, h, and k, leaving a unknown. So y equals, so 0, that's y, equals, I don't know a, and then I have x, which is negative 1, and then minus h. Now think about this, subtracting a negative 2 is going to become a plus 2, right? Plus k, which was 3. There, how's that for color coding? All right, let's clean this up a bit. 1 squared is 1, boring. Plus 3. Subtract 3 from both sides, negative 3 equals a. So going back to my formula, forget this h and k, forget the x and y. We're going to only use h and k and a going back into my formula. The y equals, I just found a is negative 3, which makes sense because it's a down opening parabola. And then x minus h, so x plus 2 squared plus 3. So you have to do a little bit of work to find the a. You can anticipate the a, like you can predict if it's positive or negative. If it's in your fat parabola, you can tell if it's going to be like a number larger than 1 or less than 1. But that's the idea for those. All right, so this next guy, we have to use the vertex at negative 2, negative 2. So there's my h and, for Pete's sake. Negative 2, negative 2 is my vertex. And then I'm going to use the ordered pair going through, thank you, buddy, 0, 0. Yep. So our formula.
How do I know?
I don't know, I'm very smart. All right, y equals, I don't know a.
I just said it correctly.
Mm-hmm.
But that's trick. If you don't do it all by yourself, no one tells you.
Right.
That was hard.
Good point.
How did I know?
I don't know.
That was very good.
Very good. All right, 2 squared is 4.
I have.
Hey, Logan, what's 0 plus 2?
I don't know.
Oh, think about that.
That's too easy.
That is pretty easy. What's 0 plus 2?
Well, is the odd.
Oh, the flashcards? Yeah.
It's already. So, you need to. You have that feel.
Oh, all right. We just found an a value of 1/2. That's why your parabola is a little wider than normal. Ow. X plus 2 squared minus 2.
Yeah.
Okay, thank you. Oh man, this is even easier. So instead of us trying to figure out where the points are on the graph, they just went ahead and told us the points. And this next one is super, super easy. They give me a really nice point. So let's see. Here's my H and K. Here's my X, whoops, and my Y. And we're gonna do the same thing. Okay. Okay. Can you sit down right there?
No.
All right. So 7 equals A.
Do a lady long.
Can you do me a favor and turn on the light?
Ha ha.
Thanks.
I can.
All right. X minus H. Minus -1 will turn into a +1.
How many is 30 plus 30?
Good question. Any other?
I don't know.
Plus
You
K.
don't need to say it.
30 plus 30? Well, what's 3 plus 3?
30.
What's 3 plus 3?
That's 4.
Plus 3? Embarrassing, Logan.
6.
Yeah. So what's 30 plus 30?
I don't know.
Got our A value, I already knew H and K. Let's do this. Y equals A. Now, the drawback to having just the information on the picture is you can't make a prediction. As far as like, is A, say positive? Is it 1/2? Is it 3? What's going on? But, all right. The next one, same stuff. Apparently, my baby's getting restless, so we're going to have to read this lesson up. Oh, man, this is not a good moment. All right, time out. I'm going to get out of here. We're back. Not happy. Mad at me. All right, so these problems we're going to be using our graphing calculator to model, and it'll kind of help us with what's going on. So get out your handy dandy graphing calculators. I'm going to get my emulator out. We're going to type in the function instead of t's. We're going to use x's because that's the way it's set up in our PIs. That's totally important that I ignored it. Okay, so go to y equals, clear out whatever the last thing that was typed in, and then type in -16. We'll talk about the significance of that -16 later. X squared plus 32, no, 132, that would make a difference. 132x, and then plus 60. All right, if you remember from Algebra 2, the significance of the -16 as the A coefficient is the effect of acceleration due to gravity measured in feet per second squared on Earth. So depending on what your window is right now, if you hit graph, I have a standard window. Not a great window for a real life problem because we are measuring time on the x-axis, which is x. Sorry, I'm back at the yellow one again. Okay, so x is measuring the time. So it wouldn't make sense to go -10 seconds and then 10 seconds. I can see that. What are we dropping here? A rocket? Or a rocket's being launched and it's going to fall. Okay, sorry, back again. So I can see that the rocket is hitting the ground. That's where I'm measuring right there on the x-axis. But I can't see the top of the rocket's path, and frankly, the x's don't make any sense. So measuring time, let's say time starts at 0. That'd be launch time. 10 seems to be big enough. But I don't mind that the height is going -10, even though 0 would be the ground. -10 would give you a little bit of like a window drop, so you can actually see the axes. But the y max needs to be way bigger. So, spoiler alert, I already did this. You gotta go big, like 350 would be big enough, okay? 350 feet up in the air, launching a rocket, so, it makes sense. Now when I hit graph, I can see the rocket path pretty clearly. So we're gonna jot that down on our screen, or my screen, your paper, where it says, got the equation. So remember, we changed everything to x's. I think I typed it right. The x's went from 0 to 10. We left it like that. And then we went -10 to 350 for the y's. Drawing a sketch. Notice it does not start at 0. It starts higher than 0. Oh boy. Pretend that was supposed to look like a parabola. All right, how tall is the building? So we're launching off of the top of a building, and we should be able to tell that the y-intercept is the start height, or however high it was before it was launched. So that would must be the 60 feet. How high is it when the rocket, how high is the rocket when you're 3 seconds into your path? So we could use our calculator to find that, or we could go ahead and plug in 3 in for the t's or for the x's. So negative 16, 3 squared, plus 132, 3 times 3, plus 60. So I already did this. Turns out it's 312 feet. And then remember, your calculator is pretty handy for finding these things as well, right? So if you just hit trace, that pulls up the cursor, and then you can type in 3 and hit enter, and it'll pop out the 312. So it'll give you any significant point there. 8 seconds in, let's use this little trick. Let's just type in 8. Boop. 9 to 2. My baby is mad. At what time did it hit the ground? Well, algebraically, you can find that answer by setting it equal to 0, but it's not going to be a nice thing to solve, okay? These are real world problems and they hardly ever come out nice. So you would have to use quadratic formula. You could complete the square, I suppose, after you divided everything by negative 16. Probably not the best method. Use our calculator to find it, okay? Where it hits the ground is called the x-intercept, also known as a 0. So you go to the trace menu and you choose the 0 finder, and then you follow the directions. So first it says left bound. It wants to make sure that your cursor is to the left of the x-intercept. So in this parabola's case, that would be above the x-axis. So we're already there. Hit enter. And then it's going to scroll to the right for a little bit. Make sure you get underneath the x-axis this time. Okay. I like how these new calculators show you the vertical, like, domain boundaries. That's nice. You can see that your x-intercept is between those two domain boundaries. Enter one more time, and it hits the ground at 8.7 seconds, which I could tell it was between 8 and 9, closer to 9, but, a more accurate answer of 8.7. Eh. At what time did it reach the maximum height? And then is there a follow-up? What is the maximum height? And then yada yada. Okay, so maximum height is this max point, which we could find using the vertex finder formula for your quadratic formula, or we could use the maximum finder on your calculator. So the maximum finder, left bound. Now mine has a bit of a delay, so you either have to drag it over to the left of the maximum, or you could make it hop if you just type in an x value that's clearly to the left. So I'm going to type in 2 because I know that's to the left of the vertex. And then I'm going to type in something clearly to the right. So how about like 6? And your maximum should be between those two domain boundaries. We hit enter one more time and it gives you a max of 4.1, 332.25. So the time is 4.1 seconds. The height is 332.25. Let's make sure we put those in the right answer blanks. Again, we could have, there we go. We could have used algebraic formulas to find that. There's no harm in doing that. So we would have done negative b over 2a, and we would have ended up with approximately that. And then to find the height, we would have taken this value and plugged it into the formula. It might have not come out to exactly 332.25. It might have been something like 332.3 because of the rounding, but close enough. At what time was it exactly 300 feet? So this algebraically would kind of be a pain because you would have to set up 300 equals and then the original formula. And then you'd have to subtract the 300 over and then use a quadratic formula or some other method to solve it. So if we already have it typed in our calculator, what if we did this? What if we went to y2 and we typed in a separate function of just y equals 300, and it's going to graph a horizontal line through 300 feet, and you're going to see that the rocket hits 300 feet twice on the initial, launch up, and then as it starts to descend, it hits it again. So at what time did that happen? We're going to find what's called the intersection. So go back to the calc menu, choose intersect, and follow the directions. The first one says, is this your first curve? And you say yes by hitting enter. And then is this your second curve? Yes, hit enter. And then when it says guess, it's going to default to whichever one it's closest to. So it's going to find the one that's on the right. I keep pointing at my screen like you guys can see that. All right, so 5.5 seconds is the second time it hits that height. Let's go find the second intersection, pull all that up again. But when it says guess, you need to get closer to the other one. Good enough. All right. So 2.7 seconds. So at 2.7 seconds and 5.5 seconds, that's when it hit a height of 300. So 2.7 and 5.5. Which, yeah, we could have found through the quadratic formula. It would have been a big, big fun time, trust me. All right, so that's the end of our lesson. It's reminding you about the different quadratic forms. We're going to be using the calculator a lot, but we want to have a backup with algebraic methods. As long as you're a savvy test taker and you have multiple ways to figure it out, you're golden. So that's what we hope for.